time always runs the same way. It never goes backwards. And we're aware of time because we notice that things happen one after another.
Time remains one of the greatest mysteries of the universe. We perceive it as a constant, always moving forward, never stopping, never reversing. But what if that's not entirely true? What if, under certain conditions, time could actually move backward? And what if scientists have, for the first time in history, observed negative time? For centuries, the nature of time has captivated both physicists and philosophers, from the ancient Greeks pondering existence to Albert Einstein's groundbreaking theories of relativity. Our understanding of time has evolved significantly, yet it has always appeared to move in only one direction, until now. At the forefront of quantum physics, scientists have made a remarkable discovery. They have observed what appears to be negative time. In other words, they have recorded instances where time effectively moved in reverse. This groundbreaking finding challenges everything we thought we knew about reality, and could have profound implications for physics, technology, and even our understanding of free will. But how is this possible? How can time reverse, and what does it mean for our daily lives? To explore these questions, we must venture into the strange and often mind-bending realm of quantum mechanics. In classical physics, time is considered a one-way street, closely tied to the second law of thermodynamics, which states that entropy, the measure of disorder in a system, always increases. This principle explains why a shattered egg doesn't reassemble itself, or why coffee and cream don't separate once mixed. These everyday experiences reinforce the belief that time only moves in one direction, forward. However, in the world of quantum mechanics, things are far from straightforward. Quantum mechanics governs the behavior of particles at the smallest scales, where the laws of physics operate in ways that defy common sense. At this level, particles can exist in multiple states simultaneously, teleport across vast distances instantaneously, and now, astonishingly, experience time moving backward. The groundbreaking observation of negative time stemmed from an experiment involving the manipulation of quantum systems in highly controlled environments. Researchers used ultra-cold atoms and precisely calibrated laser pulses to create conditions where quantum particles exhibited behavior that contradicted the typical forward flow of time. A key mechanism behind this discovery is the phenomenon of quantum superposition, which states that a particle can exist in multiple states at once until it is observed or measured. Under specific conditions, researchers found that these particles could be shifted into a state where their wave functions evolved in a manner that mirrored the past rather than advancing toward the future. This reversal of the expected sequence of events is what scientists are referring to as negative time. To put it simply, imagine striking a cue ball in a game of billiards, except instead of rolling forward, it retraces its path back to its starting position. This is essentially what was observed at the quantum level, though in a way that is even more bizarre and counterintuitive. One particularly remarkable aspect of this discovery is that it challenges our fundamental understanding of time itself. One particularly intriguing aspect of this discovery is its potential connection to time reversal symmetry in theoretical physics. Time reversal symmetry suggests that the fundamental laws of physics should function the same way whether time moves forward or backward. In classical mechanics, we don't observe this occurring in reality, but in quantum mechanics, time reversal symmetry has now been demonstrated under highly specific conditions. This raises profound questions. If time can be reversed at the quantum level, could this principle ever be extended to larger, macroscopic systems? Could we, in theory, develop technology capable of manipulating time? While such possibilities remain purely theoretical for now, the mere observation of negative time represents a crucial step toward understanding what might one day be achievable. One of the most exciting potential applications of this discovery lies in the field of computing. Quantum computing already operates in ways that challenge conventional logic, and the observation of negative time could unlock entirely new approaches to information processing. If time can be manipulated within quantum systems, it could lead to breakthroughs in error correction, faster computation, and even entirely new forms of data processing that are currently beyond our comprehension. There are also significant implications for our understanding of causality. the fundamental relationship between cause and effect. In everyday life, causes always precede effects. You flip a light switch, and then the light turns on. But what if, in certain quantum systems, effects could precede causes? Such a concept challenges our deepest intuitions about time and reality, opening up new frontiers for scientific exploration. While this may sound like science fiction, researchers are now confronting the possibility that negative time could challenge our fundamental understanding of how events unfold in reality. Beyond its implications for physics and technology, the discovery of negative time also raises profound philosophical and existential questions. If time is not strictly linear, could it mean that our past, present, and future are not as rigidly defined as we once believed? Could this lead to new interpretations of free will and determinism? If the future is not set in stone, might it be possible to influence events in ways previously thought impossible? Of course, this discovery does not mean we'll be building time machines anytime soon. The effects observed occur at an incredibly small scale, and applying these principles to real-world scenarios presents a challenge that scientists are only beginning to explore. However, just as quantum mechanics once led to revolutionary technologies like semiconductors, lasers, and MRI machines, the study of negative time could one day unlock new advancements beyond our current imagination. The discovery of negative time could pave the way for future breakthroughs that are currently beyond our comprehension. As research progresses, physicists will continue refining their experiments, testing new theories, and exploring the limits of what negative time can reveal about the universe. Though this discovery is still in its early stages, one thing is clear: observing negative time marks a paradigm shift in science. It challenges our understanding of reality and opens the door to possibilities once thought to exist only in theory. So, what does this mean for us? For now, it offers a fascinating glimpse into the deeper workings of the universe, reminding us that our knowledge of reality is far from complete. Just as past discoveries have rewritten fundamental scientific principles, this breakthrough suggests that the nature of time itself may be more complex than we ever imagined. As we push the boundaries of physics, who knows what astonishing revelations await? The universe remains vast, mysterious, and full of surprises, and the discovery of negative time is yet another reminder of how much there is still to explore. For centuries, humans have been obsessed with understanding time. From ancient sundials to cutting-edge atomic clocks, we have measured it, studied it, and tried to grasp its true nature. But what if everything we thought we knew about time was wrong? What if time doesn't just move forward but also backward? While this idea may seem like science fiction, recent experiments suggest that negative time, time flowing in reverse, might be more than just a theoretical concept. Scientists have now observed something that was once considered impossible: a system behaving as though time were moving backward. If confirmed, this discovery could fundamentally change our understanding of physics, reality, and even the fate of the universe. But what does it truly mean to observe negative time? Could this be the key to time travel? Could it help explain some of the strangest quantum phenomena? And most importantly, how might this reshape our perception of the past, present, and future? To understand these questions, we must first explore the nature of time itself, why we experience it as a constant forward motion, and whether that experience is as absolute as we once believed. We are born, we age, and eventually, we die. A shattered glass never spontaneously reassembles, and a hot cup of coffee cools down but never heats itself back up. This phenomenon is explained by the arrow of time, a concept in physics that describes why time moves forward rather than backward. The arrow of time is closely linked to entropy, which measures disorder in a system. According to the second law of thermodynamics, the total entropy of a closed system always increases over time. This explains why things break apart rather than come together, and why heat flows from hot to cold rather than the reverse. Entropy provides a strong foundation for why time appears to move in one direction. But what if there were scenarios where entropy decreased instead of increasing? Could that mean time can actually flow in reverse? For decades, physicists have debated this possibility. Now, for the first time in history, experiments have provided direct evidence of negative time. The groundbreaking experiment, reversing time in a quantum system. So how did scientists observe negative time? The answer lies in the strange and counterintuitive world of quantum mechanics, the branch of physics that governs the behavior of particles at the smallest scales. Researchers at a leading quantum computing lab conducted an experiment using IBM's quantum processor. Unlike classical computers, which use bits that represent either 0 or 1, quantum computers use qubits, which can exist in a superposition of both states simultaneously. The scientists created a simple quantum system and observed its evolution over time. As expected, the system spread out and became more disordered, following the natural rules of entropy, just like a broken egg or melting ice. But then, something astonishing happened. Using a carefully designed algorithm, the researchers applied a special operation to the system. Under normal circumstances, the state would continue evolving toward greater disorder. However, in this case, the system unexpectedly reversed its evolution, returning to an earlier state, essentially as if time had moved backward. This was not just a simple computer simulation or an illusion, it was a real, measurable effect. The quantum system behaved as though time had rewound, defying everything we assume about the natural flow of time. The implications: have we just discovered time reversal? The experiment suggests that under specific quantum conditions, time doesn't always move forward, it can also move in reverse. This raises profound questions. Does this mean time travel is possible? Could this principle be harnessed to build a time machine? And if time can flow backward in quantum systems, could it also occur in larger systems, perhaps even in the macroscopic world? Negative time and quantum superposition. The idea of time running backward isn't entirely new. In fact, certain interpretations of quantum mechanics have hinted at this possibility for decades. One well-known example is the Feynman-Stuckelberg interpretation, which proposes that antimatter particles could be regular particles moving backward in time. In this view, when a particle and its antiparticle annihilate each other, it could be seen as a single particle traveling forward, then backward, and forward again through time. Similarly, quantum superposition allows particles to exist in multiple states at once, meaning they might not be bound by the same rigid timeline as classical objects. Some physicists have even suggested that on extremely small scales, time itself may be bidirectional, capable of flowing both forward and backward simultaneously. This recent experiment may have finally provided direct evidence of this phenomenon, proving that time reversal is indeed possible at a quantum level. What about the grandfather paradox? If time can move backward, does that open the door to paradoxes? One of the most famous time travel paradoxes is the grandfather paradox. If a person travels back in time and prevents their grandfather from meeting their grandmother, they would never be born. So how did they travel back in time in the first place? While paradoxes like this make traditional time travel seem impossible, the latest findings suggest that negative time in quantum systems doesn't necessarily lead to such contradictions. Instead, it may hint at a new way of understanding time, one where the past and future influence each other in ways we don't yet fully comprehend. Could negative time explain dark matter and dark energy? Another fascinating possibility is that negative time could help solve some of the greatest mysteries in physics, specifically, dark matter and dark energy. Dark matter, an invisible substance making up about 85% of the universe's total mass, remains unexplained despite decades of research. Dark energy, an even bigger mystery, is the unknown force causing the universe's expansion to accelerate instead of slowing down. Some physicists have proposed that dark matter and dark energy might be linked to hidden dimensions of time, regions where time behaves differently from our normal experience. If negative time exists in quantum systems, could it also exist on a cosmic scale? Could entire galaxies be moving backward in time relative to us? If so, our entire understanding of the universe would need to be redefined. Could humans one day control time? The idea of manipulating time has fascinated humanity for centuries, but until now, it has remained firmly in the realm of science fiction. However, this experiment suggests that under the right conditions, it may be possible to influence the flow of time at the quantum level. While still in its infancy, the potential applications of this discovery are staggering. Ultra-fast computing. Quantum computers could potentially use time-reversing processes to correct errors, vastly increasing their power and efficiency. Reversible medical treatments. Could quantum time control be used to reverse cellular damage? This could have groundbreaking implications for treating diseases and even slowing the aging process. Time manipulation technology. If scientists can find a way to scale up this effect, could we one day build devices capable of slowing down, stopping, or even reversing time itself? Though these possibilities are still purely theoretical, this discovery opens the door to a future where time is not as rigid as we once believed.